Yeah. Weird? Yeah, I mean, ask your mom. I'm about to be teaching like in like a minute. Like, I already have people entering the classroom. All right, I'm about to stop. You good? Hurry up. Da-da. All right. Good day, everyone.
Good evening.
Good day, Mr. Ray.
How are you guys doing this evening?
Mr. Ray,
Yes.
I'm still at work. I had to stay and I don't have my books with me. It's I don't think I'm gonna be able to sit through class.
I totally understand it. I mean, I'm glad that you even signed in to let me know that.
Yeah, I was planning on last time I did it like that. I prepared for. I brought my books and I took 2 hours while I was on the clock because I was allowed to, but I wasn't counting on having to stay. And I've been here since the morning, so
Oh, wow.
I'm not gonna be able to sit through class today. I'm so sorry.
Yeah, no problem. I'm glad you let me know. Just to keep up, just make sure you review all the material that we would be doing today. And so
What would we going today?
we're continuing with the squares and cubes and then exponents and scientific notation. We might go
Okay.
on, but that might take the whole day up.
Okay.
So it's
Well, I appreciate it.
lessons
Yeah.
3 and 4 in unit 2.
I'll do my part and I'll try and get on it and work with whatever exercises we got to go through.
All right, perfect. Thank you.
But thank you. Yeah, no problem. I'm sorry, but I really need the classes because I can't start falling behind. But
Right.
I wasn't
I
counting on
understand
today.
you have to work
I
as
didn't
well.
prepare
So
for it. Yeah.
yeah.
Okay,
All
then.
right.
Well, you guys
Thank
have
you.
a good night at class, and
Yeah, and
I'll be seeing you on
enjoy your
Tuesday.
weekend. Be safe as well. See you Tuesday.
Thank you, sir. You too.
Yes, thank you. Have a great day.
You too. Thanks.
Thanks. All right, and good day, George.
Yeah, Mr. Ray, good evening. To
And
everyone.
good day, Alma and Clemente.
How you doing, Mr. Ray?
I'm doing well, thank you.
That's great.
William.
Hello, Mr. Ray. How you doing?
I'm all right, doing well. Thank you very much. Raymond, good to have you.
Sir, good day.
Here, Mr. Ray.
Who's that, Alma? Alma?
Yes.
Okay, yes, good day. Dorcas, good day as well.
Yeah, good evening, Mr. Ray.
Good evening. And Daniel B., good evening.
Good evening, Mr. Ray. I'm just getting out of work like always, and
Oh yeah, I
I'm
totally
in a
understand.
crappy area for service. It keeps on glitching on my end, so the service is pretty bad. So if it drops,
That's
I'm
why.
just barely getting out of work, so I could jump in on
Okay.
Zoom and try to
Yeah,
catch in whatever I can.
Thank you for letting me know. That way, I'm not wondering what's happening.
Okay, thank you.
Yeah, All right, and if you're driving, definitely drive safe. If you're gonna drive back and listen. Susanna.
Yeah, I
welcome.
am. I have you on my Bluetooth. Thank you, though.
Okay, all
Thank
right,
you.
perfect. Yeah, yeah. You don't want distracted driving. All right, Susanna. Welcome, Susanna.
Hello,
How are you doing?
I'm good. How are you?
I'm fine, thank you. All right, so just waiting a bit for others to come in, and I'm just gonna go run and get some water. I thought I had water right next to me, so just bear with me. I'll be right back. Okay, so let two people in just now, and welcome Justine and
Good evening, Mr. Ray.
Hi, thank
good
you.
evening, and Octavia. So good evening, both of you.
Yes, sir.
All right, so let's go ahead and begin. Any questions with the material that we were doing on Tuesday?
Yeah. Okay.
Hi.
Let me talk about this 72 for which is an imperfect number.
Oh,
I
the
tried to,
mixed
yeah,
numbers or improper fractions?
no. This example, that we should simplify it for that you give on Tuesday, 72, to do square root.
I don't even remember what the number is. You have to remind me that, George.
Yeah. You on Tuesday we try to do some exercise 72 on the square root.
Right.
Yeah, which was an imperfect number.
Oh, okay.
Yeah.
Okay, you're talking about imperfect squares. That threw me off when you said it
It's
that way.
rather imperfect square that I made a mistake.
Yeah.
Imperfect square.
Okay, so what was the question?
Yeah, but as we keep on dividing like that, I get lost. That is now I'm trying to, because I did my own after. I tried to record in my brain this afternoon how to come across the situation to rectify I came at a point where we have the 36 and the 6. But how do we come out with the complete answer? That's my point that I made a mistake.
All right, so what you want to do is find the perfect squares that are factors of 72. So
Yeah.
I'm writing the perfect squares on the side. And if you have them in your notebook somewhere, if you write them out,
Yeah,
it'll make it easier. After a while, you won't even need to reference it. It'll just be in your mind. So you're looking for one of these numbers here that can go into 72.
yeah.
And which one of those can go into the number 72?
Number 8.
Say that again?
Number 8.
Well, from the perfect squares, from this column.
Oh, I'm sorry.
No problem. 8 can go in there, but it's how many times
36?
It's 36.
Okay, 36 is the largest one that can go in there. Now, 8 times 9 does get you to 72. 9 is 1, but that's a smaller one. So we want the largest one that can go in there, so 36. And I'll do both of them so you can see. So if I do square root 36, square root 36 times what?
2.
2.
Right, the square root of 2. And what is the square root of 36 equal to?
6.
6.
6 times the square root of 2. And that's your final answer.
So I mean that I should put beside the answer 36, or I should put what is this 6? Or I don't know. Wow.
The 6, that's your final answer, the one that I boxed in.
But okay. Okay. 36.
So if you try it out on your calculator, you're going to see you get the same answer. If you type in square root 72 in your calculator,
Okay.
just if
Okay,
you just
let
try
me
it out
try.
right. Now, I'm just going to do the other one. William had said square root 8. Now, it is true that square root 8 can go to 72, but sometimes we might pick a number where we don't get a perfect square. And remember, the whole purpose of choosing the perfect square is so that you can get down to a regular number. So,
Mr. Rejo, excuse me, but when we take 26 times 36, 6 times 6 will give you 36. I'm just thinking, yeah, a point where you just go directly from the square root of 72. Because when you take it that way, what I'm thinking like that the square root of 72,
well,
I think it will give me 8.4 something. That's
right.
a fraction. That was why I had that problem.
Right, that's a decimal answer, but we don't want it in decimal form when it's asking you to do it this way. If it's asking you to give an exact value, you don't want decimals because those decimal numbers go on forever.
Okay, thank you.
So let me just show you. If you do that in your calculator, you get 8 point something, but your calculator is only going to give you about 9 values.
Yes.
Watch what happens if I put it in the computer calculator, which has a larger processor. If I do square root, I gotta do 72 first. If I do 72 and take the square root of it, notice my calculator on the computer has way more digits than what your calculator is showing. And if you got a more powerful calculator, it will go even further. And if you got an even more powerful calculator, it'll get even bigger. That number does not stop. And because of that, when you round it, when you say, well, I'm only going to choose this many, you actually change the value if you're multiplying or adding or dividing. And so because of that, if you were an engineer building a bridge, or you work for NASA, you could actually destroy something. The bridge can come falling down, the plane can blow up because of these little slight calculations. There's a whole math course on it. I had to take a math course. It was called numerical analyst. And so what you do is you study the errors that can happen when you round. So instead of rounding, what we have is this exact value. Okay. This exact value allows for us to, in a sense, condense everything into one. And we call it radical, so 6 root 2. We get back to it when we get to geometry. You see it in geometry a lot. A lot of ancient civilizations had an understanding of this. But for now, you just want to trust the process and that it does work. If you were to type this into the calculator, you would get this and put a decimal point, you would get the same answer as the approximated value here. They are equal. All right, so remember, William had said square root 8 can go into there, but remember, you're always choosing from the perfect squares. Now, it just so happens, it doesn't always happen, but it so happens that the square root of 8 times the square root 9 is square root 72. But if you choose a small value, look what happens. You have to take the square root of 9. The square root of 9 is 3. And 3. So you get square root 8. Now, that's not finished. This can keep on going. Just bear with me real fast. And welcome Norma, Marisol, and Sergio.
Thank you, Mr. A.
Thank
You're welcome. All right, so here you notice that the number 8 can be simplified again because there's a perfect square that could go into that. and that is the number 4. And so what we would have is 3 square root 8 can be equal to square root of 4 times the square root of 2. And then the square root of 4 is equal to 2. And 3 times 2 is 6. So you see how many steps you would have to do if you don't choose that largest value? You want to always make sure you choose the largest perfect square that can go into the number. You still get the same answer. It just takes you way longer if you're doing it by hand. Right, is that clear?
Yes, it's
Yes.
clear, sir.
All right, that's good. Any other questions from the from the practice that we've been doing? And forgive me, I didn't send that worksheet. I got confused with another class.
Mr. Ray, I have a question.
Sure.
I don't know if it was just me, but I thought you had mentioned you were gonna send worksheets.
Yeah, I did. That's what I just said. Forgive me. I didn't send the worksheet to you guys. I got mixed up.
Oh, okay, okay.
Yeah, so hold
Okay,
on.
thank you.
You're welcome. And actually, I'm going to do that right now because I did mean to send that to you guys before. And like I said, I got mixed up. What happened, some of you may know, I've picked up a science class because the teacher has dropped it and they needed a teacher right away. So I think some of you, I have some people from my class, I don't remember it's from this one or my morning math class, but I'm teaching a science class that was dropped on me last minute. And so that kind of threw me off. So just bear with me real fast. I'm going to try to find that worksheet right now. This one's a little difficult.
Mr. Ray, how can I join your science class?
You have to call the school to do that. You could possibly talk to Lupita in the office, and she would tell you exactly what to do from there.
Okay. And what time, what date? Is it on Tuesday and Thursday? Same?
Right now it's on one day, Wednesday right now.
Ah, shit. And was my working day. I was thinking could have been Tuesday, Monday or Tuesday, which I'm always free.
Oh, no, yeah, because most of their
Wow.
classes are at 6 o'clock. So it would have been a conflict.
Oh, wow. And Wednesday.
Mr. Ray,
Yes.
this is Salvador. Mr. Ray, I didn't hear my name on the attendance. I just want to make sure I get checked in.
Who was that? Sorry, I have the thing closed.
Salvador.
Yes, I got your name. Forgive me if you didn't hear me.
Thank you.
Yes, but thanks for checking up on it. All right, so I'm gonna put up a problem for you to try. The worksheet that I was gonna give you, I thought about it later. It's gonna be a little bit difficult. So let me give you some more just to prep your memory again. So you're gonna find the square roots of, trying to make sure I don't pick one that we've already done. 32. So find, not just the square root, sorry, the simplified form. That means no decimals. So square root 32, square root of 45, and the square root of 96. All right, so that's what you're going to try to find, and in their simplified forms. All right, so I see an answer already.
Mr. Ray, I have my answers, but I don't know how to use the computer calculator to send in my answers.
Oh, just try to type it in the best way. You know how to say it by words, so you can send.
Okay, by words? Oh,
Yeah,
okay, okay.
You can do it by words.
Got it. Okay.
Okay. All right, William, those are all correct. I know you're trying to write it with the square root sign. So yeah, that's correct.
Yes.
Mhm. Sorry, I've seen it. Have you seen it? Have you seen my own, George?
Yes, I see it. Wait, no, I don't see it from you, George. It was Gennaro I actually saw.
How did I send it? I don't know.
Gennaro, that's correct. And Dorcas, that's correct. And Justine, that's correct.
Wow. I'm saying it. It's not going.
So make sure you push enter, or just the enter button on the keyboard.
Okay. What's happened? Enter. Okay, you seen it?
Yeah, I see it now.
There's number 1, number 2, then number 3.
Okay, and okay, I see it. You wrote it with
Number 1, that is first one, then number 2, the answer, number 3, the answer. That's how I did.
Okay, so trying to see how. Hold on, there's a few people coming in at once.
Okay.
Jim, reduce them. You are eating other rice. Uh-oh. James, you're not charging my stuff. Oh.
All right, I'm just gonna send something to you guys now before I forget. I don't know if this is gonna make it disappear. Let me see something. I don't want to make it disappear, so just bear with me. Okay, so yeah, the worksheet is in there now, the one that I was attempting to send. All right, let's just go over these answers now. So I do see the different answers popping up. So for the first one, you want to choose the largest perfect square that can go into that. Some of you sent part of this, but not fully. What is the largest perfect square that can go into 32?
8 times 4.
16.
Okay, 8 and 4 will work, but it's not the largest perfect square. 16 is the
16.
largest one. So that allows you to do it in just one step. So if you use 16, and what is the other factor?
2.
2. So if you use 16 and 2, it will get you there faster in just 2 steps. So what is the square root of 16?
4.
4. So it becomes 4 square root 2.
Or
Now, if, I'm just put it over here, if you did it using square root 8 and the square root of 4, you're going to have more steps. First, you got to split up the 8. So if you take the square root of 4, that's going to be 2 times the square root of 8. But then you notice that's not the same, so you're going to have to do something else there. Square root of 8, there's a perfect square that can go into that. That can break up into square root 4 times the square root of 2, right? Because 4 is a perfect square that can factor into 8. And then you have to take the square root of 4, which is 2, and remember you're multiplying all of these. And then 2 times 2 is 4 square root 2. So you see, if you don't choose the largest perfect square, you end up with all this extra work. So make sure that you always choose the biggest one, the largest perfect square that you can find, and it'll save you a lot of work. All right, how about that second one? Square root 45, what is the largest perfect square that can go into 45?
9.
9, so we have square root 9 times what?
5.
5, and what is the square root of 9?
3.
3. And then you still have the square root 5 there. That's your final answers. All right, and then the last one, square root 96. What is the largest perfect square that can go into 96?
48.
Okay, well, 48 is large, but it's not the largest perfect
16.
square.
16.
Pardon?
16.
Okay, I hear 16, and 16 times what would give you 96?
Times 6.
4.
Okay, I hear 16 times 6 and 16 times 4.
6. My bad.
Yeah, okay, it's 16 times 4. I mean, I wrote 4.
Times
Yeah,
6.
yeah, it's because I was saying 4. All right, 16 times 6, and then what is the square root of 16?
4.
4, and then we bring down the square root 6. So those are all of our answers. Well done to those who helped me and got it right on their own. If you did, well done. If you did not, don't beat yourself over the head. You have a worksheet that you want to use for this weekend. And it has the answers attached, but we try to do it without the answers. All right, let's review how to do that on the calculator. Once I change the screen, it's just going to disappear. So does anyone need to write this down or copy it or take a picture?
No, sir.
All right, so I'm switching over to the calculator. In a moment. Excuse me. All right. All right, so here we go. The first one was the square root of 32. So if you take the square root of 32, you get our first answer, 4 square root 2, or 4 root 2. The second one was the square root of, who remembers?
45.
45.
Thank you. Square root of 45. And that will give us the 3 root 5. And then the last one was the square root of 96.
96.
So remember, you hit second. The square button, which is the green on the top, is the square root. Type in the number 96 and hit enter. And then you get the 4 root 6. All right, any questions on using the calculator or by doing it by hand?
No, sir.
All right, so just remember though, you do need to study. In my morning class, they started before you guys, so they're ahead of you. But once we got to algebra, a good bit of them forgot how to do adding and subtracting fractions. They got different stuff. So because of that, I told them I was going to do some pop quizzes. So I'm going to do the same with you guys. You're going to have like pop quizzes on stuff we've done in the past, just to make sure that you're not forgetting how to do those different things that we've already done. So stuff like ratios and proportions and things like that. All right, any questions? Oh, no, we already asked that. All right, so let's go back now. We're going to move on to scientific notation. So we're in the student book, and we're going to Unit 3. Sorry, we still need to do cubes and cube roots.
Student book, Unit 3.
For page 54.
I don't like graphing.
All right, so the other thing that we can explore.
Mr. Ray, what page?
It's page 54.
Okay, thank you.
You're welcome. Now, the reason why we call square numbers, remember, it's because if you take a square and you find the area of any square, it's simply the dimensions which are the same times each other. And so 3 times 3 is the same as 3 squares, so we call it a square. When we deal with 3-dimensional shapes, such as volume has, well, if you're dealing with a cube is a 3-dimensional 8-sided figure where all the sides are equal. So if I had 3 here for my length, 3 for the width, and 3 for the height, then I find what's called the volume. It becomes 3 times 3 times 3, which is the same as 3 cubes, because we name it after the cube. So sometimes you might hear people say 3 to the power of 3, and then other times you might hear people say 3 cubed. The reason why, once again, it's called cubed is because of the shape of a cube, which has the property of multiplying a number by itself 3 times. Okay, so cubing a number is the same as just multiplying by a number 3 times. So 1 cubed is equal to 1 times 1 times 1, which is just 1. 2 cubed is equal to 2 times 2 times 2, which is equal to 8. 2, I keep writing 2. 3 cubed is equal to 3 times 3 times 3, which is equal to 27. Right? 4 cubed, I'm not going to write that all out. But 4 cubed is going to be 64. And 5 cubed is 125. Now, normally the first 5 cubes are kind of enough to know. It's page 54 that we're working from, and I've already sent the worksheet, Latavia, if you're still there.
Okay, thank you, sir. Appreciate
You're
it.
welcome. Okay, bye-bye, be safe.
Thank you. Have a good weekend, guys.
Yes,
Bye.
well. Thank you. And where was I? All right, so those are our perfect cubes. Now, we're not going to actually do, you can do the, what we just did with the radicals with cubes, but you don't have to know that for GED. For GED, they will either ask you to write it in decimal form, or they're going to give you a perfect square, a perfect cube, sorry. So that's our cubes. And the opposite of the cube, does anyone remember or know what that is? Call it the, yeah, cube root. Yeah, cube root. So if I take the cube root of 1, I will get 1. If I take the cube root of 8, any guesses what I will get?
That's that is 2 cubic 3.
Oh, you was close, it was 2.
Oh, 2.
All right, if I take the cube root of 27, any guesses to what I'll get?
3.
3, right? It's the opposite. If I take the cube root of 64, what would I get?
Oh.
4. If
Four.
I took the cube root of 125, what would I get?
5, 25.
Right? And that's just the basic gist. You're just working your way backwards. They are opposites of each other, right? So cubing, the opposite of cubing is the cube root. The opposite of squaring is the square root. And every power has an opposite. So if I have something raised to the 7th power, the opposite of raising something to the 7th power is finding the 7th root, and so forth. All right, so not sure if anyone's copying, but you can now try some of these in your calculator. I briefly showed you guys, I believe, the other day, but we're going to go over how to do it again on the calculator. And so if I don't hear any rebuttals, I will switch over in 3, 2, 1. All right. So using the calculator, if I want to find the cube root of something, I need to first hit the number 3 to represent the cube root.
Okay.
Then I hit the second button, but instead of going to the square root, I go to the button right above it. Right above it, if you look at the green part of that button, you see X, that's a little bit small, and then the square root sign. The moment I push that, it changes whatever number I put first into a root. So if I had put 5, it would have become the 5th root. If I had put 4, it would have said the 4th root. So now this says the cube root, and I can try any of those numbers that I put in, such as the number 64, and it'll give me the answer of 4. If I do the cube root of 125, I hit the 3 first, right? Second, and then the button, and then 125. All right, I could keep on doing that with any series of numbers. Like I said, a cube root of 343, and it'll give me 7. If I wanted to find a cube root, well, I'll let you do that. What is the cube root of 1,331?
131.
Yeah, so I'm gonna write it up here. Oops, no, not
11.
Okay, I heard 11. So I'll just write it here for anybody. The cube root of 1,331. What is that answer? And I heard 11 from Salvador.
11.
11.
All right, so you guys are on point. All right, so we have 3, right? Hit the 3 first, second, hit the button, and then 1,331. And you hit enter, the number 11. All right, so make sure you practice using the calculator. It could save you a lot of trouble, especially as we go up further. You're going to see that we're going to be solving equations with square roots. And I was trying to see if there's some in the book just to show you what type of stuff we're going to be doing and why you want to make sure you know how to do this. Let me just see if there's one that can take your attention to. All right, so yeah, if you really want to get an idea of the stuff that you're going to be doing with square roots, you look on page 64. We're not doing that yet. We're not doing it today, but this is why you want to learn how to use the calculator. If you look on page 64 and just look at the example that they have there on part B, you get an idea of what we're working our way up to and why we're learning how to do all the fraction buttons and all that. We're going to make life much easier with the calculator. And so make sure you practice. But that's just an idea. Say that again?
Is it on the student book?
Yeah, if you look on the student book on page 64, you see what we're working up onto and why we're learning how to use the calculator to do the square roots and cube roots and stuff. So on page 64, there's an example there. If you look at the part B, you see like x equals negative b plus or minus the square root of b squared, subtract 4ac, etc. Do you guys see that?
Yes.
All right, so you see that big square root and then everything else underneath it. We're going to learn how to do that. Oh. So it may look hard now, but by the time you get there, you know how to do it. But one step at a time. So you definitely want to make sure you're in class each day as we build up to that. All right, so back to page 54. That was just a quick commercial break to show you why we really want to master this. Now, if you look back on page 54, you notice they have some examples there in that little box on page 54. So we're back to the lesson we're on. And if you look closely, you see the two last ones at the very bottom. You see the square root of -9. What does the book tell you the answer is there?
On which page? 54?
From page 54.
Is it,
On,
underlined?
okay.
It says undefined. You cannot take the square root of any negative number. It's impossible. Cannot happen. So what happens if you put in the calculator, it's going to come up domain error. Domain error is the same as what the book says, undefined. That means there's no value for it. It's impossible for that to happen, right? There's no way that you can take the square root of a negative number because there's never a time when you can multiply two numbers and get a negative number. If you multiply -3 by -3, you're going to get +9. You cannot, and it's impossible to square a number and get a negative. And because it's impossible to square a number and get a negative, it means there's nothing that exists if you take the square root of a negative number. There's no answer because there's no possible way to multiply two numbers together and get a negative. And because of that, it's undefined. Like I said, if you try any square root of any negative number in your calculator, they will all come back as domain error, which is the same as saying undefined. So you see here, square root of -6, domain error. If I change it to 156, domain error. Same as undefined. Now that is only the case for square roots or any other even powers, which you don't have to worry about. But for GD, that's only true for square roots, not for cube roots. Notice, what is the answer for the cube root of -27?
-3.
-3, and you can try that in the calculator. If you do the cube root of -27, you will get -3. And that's because -3 times -3 times -3 is going to yield a negative number. Two negatives make a positive, but when you multiply it by another negative, it turns it back to a negative. And 3 times 3 times 3 is 27, which means the cube root of -27 exists. It's -3. Right, so those are...
How did you type that on the calculator? I typed it as and then the negatives over here on the parenthesis part, or what?
Yeah, you want to push the negative down here, not the subtraction sign.
Oh, okay.
Remember, if you use subtraction sign when it's a negative, it will come up as an error. It will say syntax error, I believe. Is that what it said?
Yes.
Yeah.
So which one do we, which negative, which sign?
Got it.
Well, it's only one negative sign, and that's the one down bottom.
The one between the parentheses.
Yes, that's negative. This one is subtraction.
Okay.
Oh, the one inside the parentheses?
Yes, that's the negative button.
Okay.
You don't use the subtraction button. If you use the subtraction button, it will come up as syntax error. Okay? All right, so we are done for now with cubes. I know you see some questions there, but it has some algebra, and we're going to come to that later. Right now, we just want to learn about how the cubes and squares and exponents work, and this leads us now to scientific notation. Now, we haven't done any scientific notation yet, right? That's the next page over, number 56. If you turn over to page 56, you'll see that. And I'm going to bring up a PowerPoint on this as it's a little bit more descriptive on how to do this. All right, so remember when we were learning about exponents, we had briefly gone over this, that exponents are basically showing you how a number is multiplied by itself. You shouldn't need to write this, we've already done it. Just a quick recap. Remember, the number that is multiplied by itself, we call that the base. And the amount of times that it's multiplied, we call that the exponent. So because 7 is the number here being multiplied multiple times, 7 is the base. Because 7 is being multiplied by itself 6 times, 6 is the exponent. And so we can write it in a condensed form as 7 to the power of 6. Does that make sense?
Yes.
All right, that's a quick recap
Yes.
of what we've done. Remember, we can say 7 to the power of 6, or 7 raised to the 6th power, etc. It's no different than 7 squared. We could say 7 raised to the 2nd power, or 7 to the power of 2. Similarly, 7 cubed, we can say 7 to the power of 3, or we can say 7 to the 3rd power. Actually, you guys haven't written this. Forgive me, sometimes I'm going to mix up your classes because you guys were actually far behind my other class because you started like 3 weeks after them. But now you're only like 2 lessons away. So it kind of confuses me sometimes. I think you're the other class. So this is your first time seeing this. So you want to get that down, whether you're writing it down or taking a picture.
It's kind of self-explanatory, but yes.
Yeah, if you understand it, I mean, it just makes sense. But if you need it just for reference sake, there it is. All right, looks like those who were copying have copied that down. Okay, so what we want to do now is look at what we call the laws of
Sir, okay, just put it back behind. Let me just copy a bit, sir.
Okay, I thought I saw everybody finish.
Okay, to the power of 6. Okay.
Yeah, you got it?
Yeah.
All right. Okay, so now what we want to look at now is what we call the laws of exponents. Now you can see this briefly on page 56. There's a little box there. It doesn't go into depth, but they do want you to know all of these things. Now the laws of exponents, we use them from basically here on out. You're going to see them in algebra. You're going to see it appear in geometry. And so you really want to become accustomed to these rules. And they're common sense. Everything in math is based off of common sense, believe it or not. A lot of people think this is just foolishness. In reality, it is not. It is based off of stuff, as you have hopefully been seeing, that we build up off of things that we can just observe and we keep on building. And that's why we live in this so complex world. That's why we have smartphones that can take awesome pictures and video. It's because we're learning more and more about manipulating the world around us. So we have here the laws of exponents. Now this is the first law. And it says a to the power of m times a to the power of n equals a to the power of n plus n. What does that mean? Well, if your bases are the same, if you have the same base, then what you can do if you're multiplying is to add the exponent. So if the bases are the same, remember the base is the number that's being multiplied by itself. So if the bases are equal or are the same and you're multiplying, so we're multiplying here, add the exponents. All right, that's just a shorthand. But remember, if your bases are the same and you're multiplying, you are adding the exponents. So what does that look like? Well, first let's build ourselves up here. Let's say I had 3, come on. Let's say I had 3 to the power of 2 times, for something, like I said before, you might have heard me say this many times. It's something about the left side of my screen that just does not want to work with me. All right, so if you see any little spaces, just try to fill them in your mind. So 3 squared times 3 cubed. Because the bases are the same, the 3's, and I'm multiplying, then what can I do with the exponents according to what I just wrote?
Add them up.
Add them up. Now the reason why is 3 squared literally means 3 times 3. And put it real fast. I think my screen just needs to be clean. I'm just try to wipe it down just a bit.
Mr. Ray, which one do we go with? You said if you have the same base, then multiply the exponent.
No. Add the exponents.
Okay, just adding, not multiply.
Not multiply. If you're multiplying the bases.
So you multiply the bases and add the exponents, right?
Right.
So that'll be 3 times
No.
3.
Say it again.
So you multiply the bases and add the exponents, or what?
Okay, let me write it out. I was hoping to just write this in shorthand. All right, so if you are multiplying bases,
Oh. So I see. I think I know what you're doing, Mr. Ray.
good. That's what we want. I thought cleaning this would help. I don't know. I must have some.
So would that be 3 to the power of 5?
Here you go.
Okay, got it.
That's the answer. 3. There we go. 3 to the power of 2. That's a 2, right? I'm gonna try it again. If it doesn't work, just know that I'm trying to write a 2 up there. Can everybody make that out as a 2?
Yes.
All right, thank you, because I don't know, something wrong with my computer. It just happens every time, every day, every class, just in that left corner, it doesn't want to write. So I might have like damaged my screen or something. All right, so 3 squared times 3 cubed, as Salvador said, it would be 3 to the power of 5.
5.
Right? What you're doing is you're adding the exponents. Now the reason why is 3 squared literally means 3 times 3. And 3 cubed means 3 times 3 times 3. And how many do you have there altogether? 5. 1, 2, 3, 4, 5. And so the rule is, if we're multiplying bases, and the bases are the same, then whatever the exponents are, we can just add them. Now this comes in handy because you will see, and it happens in real life, that we can have something like 5 to the power of 18 times 5 to the power of 22. Now, sometimes we may not want the answer right away. We might just want to simplify it. And so if we need to simplify it, then we can add the exponents and say 18 plus 22. And 18 plus 22 will give us 5 to the power of 40.
40.
Right? And so now we can just have that set, and when we're ready, we can find out what the answer is. But for now, we're just simplifying it. Okay, so those are the rules. Let's try another one. Let's say I had 2 to the power of 7 times 2 to the power of 9. Because the bases are the same, what would be my simplified answer?
2 to the power of
Power
16.
of 16.
Yep, that's correct. 2 to the power of 16. And you can work them out separately and see you would get the same answer, but right now we're just working on simplifying. We're not trying to evaluate. Evaluate means to find the actual value. That means you actually go ahead and multiply it out. But sometimes, especially when we're dealing with software programs or whatnot, we just want to simplify it and let the computer do the work. Right, so that's our answer there, 2 to the power of 16. Okay, any questions before I clear all this?
Let me take a picture of that.
All right.
I'm coming to.
Good.
All right, can I clear this now?
Yes.
Yes.
All right, in 3, 2, 1, I'm clearing it all. All right, so the next rule that we have here is the division rule. The same definition, basic definition, just that you change it from multiplication to division. Now, I don't remember the exact words I wrote, but you could rewrite that paragraph over and just change it from multiplication to division and from addition to subtraction. I'm gonna try to write it again, but if you don't like my second explanation, just rewrite it and remember to change the operations. All right, so what we're gonna have here is if the bases are the same, if the bases are the same, and you are dividing, then you will subtract, the, so you subtract the exponents. All right, so because we're dividing these bases here, then we subtract the exponents. All right, so we have a to the power of m divided by a to the power of n. And so because of that, we divide. So if you have another example here, let's say we had 5 to the power of 5 to the power of 8. And remember, to divide, you could use a fraction bar. And so we could write it as 5 to the power of 3. So what we do here is we simply subtract. Right?
Excuse me, sorry.
Yes.
I think that just put the 5/8 on the position of AM. I think that it could be like that.
Say that one more time.
That is 5 in the power of 8 should be on the position of M. Then
right,
5.
That's the M.
Okay, that is why I'm talking, so that will be easy before we go to the division.
Yeah.
Okay.
So when we write this, it's going to be 5 to the power of 8 subtract 3. And what's 8 subtract 3 equal to?
5.
5. So that becomes 5 to the power of 5.
Okay.
Now, the reason why that works, if I was to write this underneath, I have 5. Remember, 5 to the power of 8 is 5 times 5 times 5 times 5 times 5 times 5. 1, 2, 3, 4, 5, 6 times 5 times 5. So there's 8 of them over 5 times 5 times 5. Does that make sense? That's a long way.
Yes.
Now remember, we learned that if you do put a number.
Cross it out.
Pardon?
I said we can cross it out from top, bottom,
Yeah,
top,
we
bottom.
could cancel each one. 5 divided by 5 is 1. It cancels out. 5 divided by 5 is 1. That cancels out. 5 divided by 5 is 1. It cancels out. And how many are you left with?
5.
5. 5 to the power of 5.
Yeah.
And so because of that, because of something we already know from Unit 1, we can create a rule for it. And the rule is when we're dividing bases that are the same, we can subtract the exponents. All right? Does that make sense?
Yes.
Yeah.
Yes.
Okay, so let's do a few examples. So similarly, if I had large exponents, right, and I was saying 3 to the power of 17, and I was dividing 3 to the power of 12, and they just wanted me to write this as a single power, then what would this equal?
3 to the power of 5.
3 to the power of 5,
Oh,
right?
5.
So 17 subtract 12, and that's going to equal to 3 to the power of 5,
Oh, 5.
right? And if I did a second one there, if I had 15 to the power of 6 divided by 15 to the power of 3, let's do a different one, 4, then what would my answer be? As a simplified form,
15 the power of 2.
15 to the power of 2. You subtract 6 and 4.
Okay.
All right, so that's how we simplify. We're not finding the actual answer, the values. We're just simplifying.
And if you, Mr. Ray, I know I'm jumping the gun here, but if the actual answer would be 30, right? Because you got 15 to the power of 2.
Well, close. I know that's what it looks like, but that's the power. So you have to say 15 times 15.
Oh, okay.
Right, and 15 times 15 is going to be a little bit larger than 30.
Right. Oh, yeah. My bad.
No problem. That's something that we definitely want to work on. But 15 squared is going to be 225 as a value. So if they told you to find the value or to evaluate, that's what you would do.
Then you multiply 15 by 15 and 15 times 2.
Right. And you could do it in the calculator too. You could do 15 squared, which is 225.
That's just the power of 2 will be the times you're going to be multiplying the 15 by. So if it
Right.
it'll be 15 times 15 times 15, 15, correct? Not
If
15,
it was to the power of 3, yeah.
right. Not 15 times 3, which will give us 45. We'll definitely get around to, okay.
Right, because remember, that's what the powers mean, this, to multiply by itself.
Number by itself, okay.
Yeah. And so like 3 to the power of 5 is 3 times 3 times 3 times 3 times 3.
Right, not 3 times 5.
Right.
Like I was doing, okay.
All right?
Mr. Ray.
Yes.
Yeah, just a question. On the number 2 you make at right way at the bottom, it is 15, 2. So the answer is 225 when you make the test?
Well, no,
Or where do you stop?
It all depends on the question. Most times, if they're asking you to simplify or just write it as a power, that's your answer. It's just that Salvador had asked me what would the actual answer be, and he said it would be 30. I was like, oh no, it's 15 squared. So it all depends on the question. The question might ask you to find a value. The question might ask you to leave it like this.
So we just
so right.
Thank you.
Okay, you're welcome.
Yeah, so right there where you had the 15 and 2, that's a PowerPoint answer. That's how it goes?
That would be the answer if, depending on the question. They just ask you simplify it or write it as a power, or what expression is equal to the expression there, that's what the answer would be. Like sometimes they'll write it like this. They'll say, what expression is equal to 15 to the power 6 divided by 15 to the power 4? And this might be one of the choice selections.
Okay.
Which means you would have to know, oh, I can apply the laws of exponents, so 15 squared is equivalent to that expression. Meaning, equivalent meaning the same.
Okay. All right, thank you.
You're welcome. Now this comes in handy. I know right now it might not make sense why we're doing it, but right now we're just learning the foundation. We make more sense once we get to the real application of it.
All
But
right.
for now, you just have to kind of trust me and see the process. We're using what we already know, right? We already know this stuff, hopefully, that when you divide a number by itself, it cancels out to 1. And so since it cancels out to 1, when I have exponents, I can realize that when I'm dealing with exponents, I can apply these laws and I could turn something that looks really difficult to something really easy. And we call that
All right.
simplifying, making something simple. So for instance, depending on your career choice, you can end up, whether you're dealing in the banking system, especially when you're dealing with trillions of dollars and multiple payments, such as what comes through the banks. We have, 350 million people in the US and possibly 200 million workers or so. And if you have all these different people getting loans, and if you understand how loans work on stuff called interest, and they accumulate yearly. And when they do that, they write them in terms of powers. So this could represent something in the banking industry, 3 to the power of 3. And we'll get to that later on. But 3 to the power of 3, right? Let's just say all do your computation, you're working, and you come up with something like this. 3 to the power of 3 times 3 to the power squared times 3 to the power of 4. Actually, let's make them higher, right? And let's say you're dealing with like 4 different people's accounts. And you're like, man, I can't work with this. Friend comes along, well, why are you working with all that? Why don't you just simplify it? And you're like, what? What do you mean simplify it? And they're like, oh, don't you know when you're multiplying bases, you can do what with the exponents?
And
Add them.
Add.
So your friend shows you, you know what? Instead of doing that multiple times every single day, why don't you just add your exponents? And you're like, what? I mean, I didn't know I could do that. And then he shows you this. And you're like, oh, okay, this is going to make my calculation easier. And so you say 3 to the power 49. Which one is easier to write over and over? This row or this row?
The one on the bottom.
The one on the bottom. And like I said, as we go up higher, you're going to start to see where this comes in handy. Right now, you're just learning the process. What do you do when you see it? All right, and so these answers are both the same. The same way, if I took it down to something really small, if I had 3 squared times 3 cubed times 3 to the power of 4, if I was to work that out, I would see that that answer would be the same as 3 to the power of 9.
9.
And if you tried it in your calculator to actually find the actual value, you will see that they both yield the same answer. Both of them are going to be equal to 19,683. It's just that this one is much easier to work with. All right. I'll give you one more example where this comes in handy, right? Let's say you're dealing with dice. Let's say you make die. That's what you call them, and they're in plural. So let's say you're the one who manufactures dice for what do they call that place? Las Vegas, right? And you're trying to find the volume of these little cubes, because that's what a dice is, a cube. And let's just say, they're not this big, but let's just say each one was 3 inches. We're just using that for an example, 3 units, right? And so you're like, well, I don't really want the answer right now, but this is going to be 3 to the power of 3. But let's say we're going to get a whole bunch of these, right? If I got 5 of these, right? And let's say I was stacking them up in little groups, right? If you used to stack one up, stack them on top, stack them on top, and that's how you were boxing your die. And you were boxing all of these different dies, then what you'll notice is that you can come up with multiples. And so you might have 3 to the power of 3 times 3 to the power of 3. And then 3 to the power of 3 times 3 to the power of 3, and so forth. And let's say you have to write a report of how many dive were in this little box that you were shipping to Las Vegas. Do you think the person who's receiving it will want it to be written this way?
No.
No, and let's say you're just writing it in a format so that they can change it depending on the size. And so if you was like, okay, well, you could change it based off the size, but this is how many, you could just add them all up, 1, 2, 3, 4, 5, and say 3 to the power of 15. And whenever you're ready, you could change it to 4. If you needed 4 inches or 4 units, you could change it from 3 to the power of 15 to 4 to the power of 15. If you need to change it to 7 units, then it'll be 7 to the power of 15. You get the picture?
Yes.
Yes.
And so it allows for us to work with these things in a very condensed fashion. All right, let's move on. The next rule is the zero power rule. Now, the zero power rule is very simple. Anything raised to the power of 0 is 1. Anything. So if I say 7 to the power of 0, what does that equal to?
1.
If I say 8,432.56 raised to the power of 0, what does that equal?
1.
1. If I said x, y, raised to the second power, raised to the 0 power, what would that equal?
1.
1.
Now, the reason why it equals 1 comes from prior knowledge. And that prior knowledge, we're going to show you what that means. If I had 5 to the over 5, what does 5 divided by 5 equal?
1.
Okay, if I had 5 to the power of 3 divided by 5 to the power of 3, what would that equal?
1.
That equals 1 as well. Any number divided by itself is 1. But according to this rule that we just showed that we got from multiplication, how could I rewrite this?
5 to the power of 0.
And so what we can conclude through logic is that 5 to the power of 0 is the same as 1. Does that make sense?
Yeah, so any number, any given number to the power of 0, it'll end up on 1. Is that correct?
Always 1. Any number to the power of 0. You could try it on your calculator. You could put all these different numbers and raise them to the power of 0, and they will all come out to be 1 based off of our previous understanding. So that's what we're doing. We're just building up off of our previous understanding. All right, does that make sense?
Yes.
Okay, and you see in a moment why this all comes in handy. Can I clear this?
Yes.
All right, and then the last rule that we're going to look at today is what we call the negative power rule. Now, how the negative power rule works, you see here, a to the power of negative m is equal to 1 over a to the power of m. Now, that might look confusing at first, but let's go over why that's true. If I had, let's say, 1 over 3 to the power of 4. Remember, the number 1 is also equal to any number to the power of 0. So that's the same as saying 3 to the power of 0 over 3 to the power of 4. We're just using some logic. And what's another way to write a division with exponents? Well, I could subtract them. 0 subtract 4. And what does 0 subtract 4 equal?
-4.
-4. And so what we can conclude is that when we have any number to a negative power, it is the same as rewriting that number by flipping it, reciprocating it, and changing the negative to a positive. Does that make sense?
Wow. Okay.
You take my word for it for now. Let's try some. Okay, so if I had 5 to the power of -2, what does that equal? Well,
I can see, let me see.
Becomes 1 over 5 squared. If I had 6 to the power of -7, what would that equal?
6 1
Oh,
over
6.
Power 7, right? If I had 16 to the power of negative 17, what would that equal? What is it equal to?
The 1
1
over 16
over
or
16 over 17. I mean, over to the power
16
of
over 7.
17, right? And notice that the powers become positive. So each time we do that, we are taking those numbers and they're becoming positive numbers. All right, what if I had 2 to the power of negative 81? What would that equal as a positive exponent?
same thing, Mr. Ray. 1
2
power 81.
Yep, there we go.
Okay.
Now, is that making sense?
It's starting to. It's starting to.
Yeah.
Starting to, good. Now, the reason why we can do that comes from here, right? We started off as something we knew. The very first law, we just used something we already knew, and we just worked our way down until we come with all these different laws. And what this allows us to do is to work things out so that we don't always end up with decimals. It allows us to simplify really large formulas and expressions down to something that's really small. And like I said, once we get to algebra, you're going to start to see us really implementing this.
He's looking algebra yet?
Pardon? Somebody asked about algebra? Okay.
Mr.
All
Ray,
right.
so
Yes.
Mr. Ray, so question. So the like this one, the 1 over 3 to the power of 4 equals 3 to the power of 0, and then 3, 4. So obviously the 3, 0, it's 1. Is that why you make that 1 over 3 over the power of 4? And
Yep.
then you come up with the 3 with the negative 4. That was the second one. Okay.
I was showing you that 1 and this, they're the same. That's what you saw. We got that from that rule. So 1 over 3 to the power of 4 can be written as 3 to the 0 power over 3 to the power of 4. And then once we do that, hopefully you remember the second rule that you can subtract the exponents since you're dividing. And then you get 3 to the power of negative 4. And so therefore we can conclude that any base to a negative power can be rewritten as 1 over that base to the positive power. Now, I know this is different because we left Unit 1 and we're no longer in Kansas. We are in the middle of the earth. So it might seem a little bit challenging at first, but with practice, never shut down. Sometimes people see this like, forget it. If you do that, you will not have success. What you want to do is try to reason. I've been commending Salvador a lot because he repeats it back to me. That's what you want to do. Some people don't think that's necessary, but that is literally how you learn. We call that, as a name for it in research-based learning, it's called processing. If you can repeat it back, you are showing that you learn. That's how babies learn. That's how we learn as human beings. So when you're talking to your baby, I'm pretty sure all of us have had children here, your baby will copy everything that you do. That's how the baby learns, right? You go to the kitchen and you drink, the baby will pick up a cup and copy you, right? It's social learning. They're learning by copying. And so if you can repeat it back, right? Say, you know what, let me try to say the same thing he just said. You are doing the steps that helps you to retain the information. All right, let's do a little test of this. I'm gonna clear all this and let's see if you guys can follow the rules. Number 1, I'm gonna mix it up. Let's say somebody gives you 3 to the power of 6 and divided by 3 to the power of 2nd, what would that be? Number 2, somebody says to you, 4 to the power of 2 times 4 to the power of 3, what are you going to write? What is that? What is the simplified form of that? Number 3, somebody gives to you 5 to the power of negative 6. What are you going to tell them that is equal to? And then somebody else gives you 176 to the power of 0. Go ahead and simplify each of these for me, please.
Mr. Ray, do we send you the answers or we say it to you?
Yeah, you can send the answers in, yes. That way I can see how is everybody doing.
Oh boy, I don't, the problem is typing. I don't know how to put it in.
You can use the same button that we use in the calculator, and that button can be found if you're on a computer. You can find that button with the number 6.
The computer.
And are you on a laptop or a desktop?
On a laptop.
Okay, if you're on a laptop, look at the number 6, and above the number 6 is this symbol here.
Oh no, the internet.
And the way that you get to that is similar to
Number
the calculator. You have to hit shift to get to that button. And when you write it, you just say 3.
Oh, okay, I found that.
Button, and then 4. Doing that means 3 to the power of 4.
Oh, Mr. Ray is frozen.
I'm frozen? Am I still frozen? Can anyone else hear me?
Yeah, we can hear you.
I can hear you.
Okay, so it might be Dorcas then, on her side. Or you could write it out. Susanna wrote hers out in words. She said 3 to the power of, etc.
Okay,
Right.
let me write it. Let me write it out in words.
Okay.
Mr. Ray, I'm sure about my first 2, and I have a doubt about my last 2, but I still send them what I thought it was.
Okay, yeah, go ahead and do that. Oh, I see it, yeah. So I'll check it. I have a few that have sent their numbers in. Justine, I just saw it. Okay, great.
Sorry, thank you.
Yeah, we sent it like the same time. And Salvador, I'm thinking that 1 in front of your 5 means that's your numerator.
Yes, sir.
Okay. And then you skip number 3. No, you skip, oh, you have them all. Sorry, 3.
Yeah.
Okay, yeah, those are all right.
How do I write this? 1 over.
And William, I'm thinking your third one. I think for the third one, you guys are possibly having problems trying to write that one up. You could write it in words. That's what some people are doing to make it easier.
Okay, I'll do that.
Okay. All right, Gennaro, those are all correct as well. All right, a good bit of you guys are getting them all correct. Well done. All right, Alma, I did understand that. That's correct. Just send me the last one, Alma.
How many problems do we have?
It was 4.
Yeah, I think I did everything.
All right, Dorcas, that's correct as well. Well done. And Marisol, well done on the first 3. All right, so a good bit of you guys have sent your answers in, so let's start going over them. And you got, if I told you to send a correction in, you can still try to send it in before I go over them. And if you haven't sent it in, you can still send it in before you go over them as well. All right, let's start off with the first one. That's division. And so when you're dividing bases that are the same, if they're not the same, there's nothing you can do. You just leave it alone. But those bases are the same. And because they are the same, we can fix it. All right, Adriana, and I think you by the stars, you mean to the power of. And I like the creativity there. Yes, those are all correct. All right, so 3 to the power of 6 divided by 3 to the power of 2 would mean that you are subtracting, as most of you have sent in, and so that's 3 to the power of 4. Okay, 4 to the power of 2 times 4 to the power of 3. What does that mean you're doing?
Adding.
Adding, so 2 plus 3 will give you 4 to the power of 5. How about 5 to the power of negative 6?
It's 1 over 5 to the 6th.
Right, 1 over 5 to the power of positive 6. And then anything to the power of 0 is just
1.
1. All right, and a good bit of you, almost all of you who sent it in, either got them all right, or you might have messed up a 1, and the mess up could have just been you didn't know how to type it correctly.
Yeah, I didn't know what happened, Mr. Ray.
I heard 3 people.
Quick question. Number 3, does that? What's the correct way of saying it? 1 over?
Yeah, you could say 1 over. That is not the correct way. It's the more it's the popular way of saying it.
Okay. 1 over 5 to the 6th. Okay.
If you say 1 over 5 to the power of 6, most people will say, oh, okay, I know what they're talking about. But it's really, you're supposed to say like 1 divided by 5 to the power. So, yeah, the over is just that so many people have said it that they just allow for it to happen.
Okay.
But it's really 1 divided by 5 to the power of 6, or anything of that nature, any mathematical definition. All right, now let's up. You're welcome. Let's up the ante a bit. Actually, no, we can't yet. We're going to learn this when we go over the order of operations. Okay, so that's what we're going to do for now. We're going to go a little bit further. And if you open your book to number page 57.
Okay.
Page 57. On page 57, we're going to try number, not hashtag. I grew up when that was number. So number 3.
Yeah, me too.
Yeah.
Me too.
Yeah, I do that in younger children, like hashtag 3. Like, no, that's number 3. So,
number or pound? That was pound for me too.
Well, yeah, it was pound, but teachers used to write number when I was young. But yeah, that was pound, and teachers would say number, and then it changed from pound to hashtag. So 3, 5, and 6, and we're gonna try 8. I was hoping to finish this before, but it's fine. Normally this takes long. The exponents and scientific notation can take some time. All right, so let's try number 3. I'll give you a prompt there because we haven't done area yet. But the area of a rectangle is length times width. So if you know the length and you know the width, then you're multiplying them. So for number 3, when it says the area of the rectangle is 2 to the power of 6, and you're multiplying it by 2 to the power of 5, what will that equal? A, B, C, or D?
B.
B. B.
B.
B, right? Because
Yes.
2 to the power of 6 plus 5 is going to yield 2 to the power of 11.
Yes.
11.
The bases stay the same, just add the
Bases stay the
exponents.
same, add the exponents. Well done.
Perfect.
All right, how about number 5?
Which is the same value as
Now
5.
this one here, we didn't really practice it right now, but we have practiced it earlier. So this is
Take a
something
while,
that we
yes.
done on Tuesday. So this one's asking for the value. Remember I said it's the difference between simplifying and finding an actual value.
Oh,
So,
that took a while.
So can I guess that one?
Yeah, go ahead.
A.
Uh,
Number 9.
C.
I'm going with C.
C?
I heard I heard 2 C's from Salvador and Gennaro, I believe.
Yes.
I'm guessing C, yeah.
All right, and then I heard a 9 from somebody. I wasn't sure who said 9.
Me, I said A.
Okay, I heard two 9s. All right, let's look at this carefully using the laws that we learned of the exponents. We learned this on Tuesday. What is 5 to the power of 1?
5.
5.
What is 4 to the power of 0?
1.
1.
1. So what's 5 plus 1?
6.
6. So it is C. Well done, you guys who said C. Be careful because
I'm
look
totally
at what,
lost because my network is unstable, so I don't know.
pardon?
I said my network keep logging me out, so I don't know.
Oh, so you got logged out for us. We're basically doing number 3, 5, 6, 8. So just in case you get logged out, those are the numbers we're doing. 3, 5, 6, 8 from page 57.
Okay.
All right, so be careful because look at the very first selection. A was 9, and it's very tempting to say 5 plus 4 is 9. And they put that right in front of you. That's one of those trick questions that they get a lot of people with. But you want to look at it carefully. Oh, 5 to the power of 1 is 5. Anything raised to the power of 0 is 1. So 5 plus 1 is 6.
So how did we come about 6?
Say that again.
How did we get 6? Is it
Because
okay,
4 to the power of 0 is 1.
Is 1. Okay.
And 5 to the power of 1 is 5. And what's 5 plus 1?
6. Okay.
And that's how we get the 6. All right, any questions on number 5?
No.
All right, I'm about to clear everything because number 6 is going to take some thinking. All right, number 6. Number 6, you can go ahead and try it. We'll see if you guys do better than the other class. So we have 5, 7 to the power of 2 times 7 to the power of 2 plus 5 times 7 to the power of 8 times, did I skip something? I did. Hold on. 7 to the power of 4 times 7 to the power of negative 4. And then subtract 7 to the power of 8 times 7 to the power of negative 4. Now, I'll be very happy if you could get the final answer without looking in the back.
I'm working, Mr. Ray. I'm working on it.
All right, go get it. Now remember, you're simplifying because it says which of the following expressions is equal to that. So when you look at A, B, C, or D, notice they are not values. You're not finding the value, the answer. You are condensing this using the laws of exponents on the left. So look at each one carefully.
I'm looking at my notes. I know I got it here somewhere.
All right. Everything that you've done, everything that
I'm halfway there.
is
I'm
from the
halfway.
laws that we have here and from things that we learned in Unit 1. So I'll give you guys some time to think about it.
I think it's in my, I wonder if I could look at my pictures by not logging out.
I already sent it, Mr. Ray.
All right, let me go ahead and look there. Okay, not quite.
I'm actually stuck up. The negative exponents was throwing me off. I can't look at my notes, but I don't have nothing on there that I could use to work with. So I'm stuck.
Yeah.
But I took a while to guess just by looking at. Sometimes by looking at it, you can actually see what it is.
Sometimes, yeah. But remember, you want to choose the selection from number 6, A, B, C, or D.
Here, let me send you to. Maybe maybe my eyes are correct.
All right, and I see here a guess for C, D, and A. So we have C, D, and A as choices.
I wonder if I got it right.
I see another answer. So remember, in order to do this, look at your bases here and think about what you're doing for each of these. Like I said, this one is a little bit challenging, but at least you can see the level of questions that they can ask. All right, so I don't really see any more answers coming in, so I'll go ahead and start it. So I have a good bit of guesses. It looks like all of the answers have been chosen except for B. So I have C's, D's, and A's, and an A.
Mr. Ray.
Yes.
So our first one, you're gonna explain it right now, anyways, right?
Yeah, I was gonna explain it, but you could go ahead and try to reason. I like when people do that.
So 5, it'll be times 5 times 7 to a power of 4.
Okay. Yeah, there we go.
Yeah,
Let's slow down. That's correct. Everyone heard what Salvador said. That's correct because the
I
sevens.
see where it is. I see where it is. And then it'll be 5 times 0. Is that right? Because there's 7 to the power of 4 positive times 7 to the power of 4 negative.
Yeah, and those add up to 0. Well done.
It would be 5 times 1 equals 5, no?
Yeah, you're on the right track. You are on the right track. That's going to be 5 times 1, which is just 5. But we still have that other one. I'm just going to, for space, 5 times 1 is just 5.
Okay.
All right, and we still have that other side there. What do we do with that?
The other will be 7 to the power 8 times 7 to the power negative power 4. So that'll be, wouldn't that be 7 to a power of 4?
Yeah, that's correct. And now we need to decide what to do with that, because so far this is correct. But if you look at your choice selections, that's not on there. So some stuff we can still do with this. And
okay. So you can minus the 7 to the power of 4 to the 7 to the power of 4. That will leave you with 10.
you're almost there. You had the right logic.
Okay, I give up.
You literally said it correctly. Like you literally said it correctly. It's just that the finishing needs to follow. Like what you said is correct.
I didn't understand it.
Would it be easier? Would it be easier to add the bases, the ones you have to add first?
Okay, how?
Like the 5 plus the 5.
Not quite. Not that one. You were on the. You do have it kind of there. That's kind of the explanation. All right. Well, let's. If anyone else wants to give it a go, if not, I will. I see somebody has the answer there. Did you just guess the answer? Did you look in the back? Do you have a reason? Hopefully, no one looked at the back yet.
No.
All right. So let's go over it.
I just 7 to the 0 power equals 1.
Yeah,
and
that's
I
the part.
subtracted the 5, take away 1, and I got 4.
5 take away what 1?
Hold on. Let me look at my notes. Hold on.
Five.
All right. So while she's waiting, I don't want to. Time is ticking away. And I
Sorry,
know
I'm trying to figure that out.
no problem. Maybe this might help. What does 5 times any number mean?
Just.
Well, let me give you a little commercial break. So there's a little line underneath. It's a commercial break, just in case somebody's like, how did you do that, Mr. Ray? So hopefully no one is there. This is a commercial break. Everybody hear what I said?
Yes.
All right.
Yes.
Hopefully no one asks me that, like, what are you doing, Mr. Ray? All right. So this is a commercial break just to help you to remember what 5 times a number is. So if I have 3, actually, let me use the numbers that are there. Might spark something. If I had 7 plus 7 plus 7 plus 7 plus 7, what's a shorter way to write that?
7 to the power 8
7 to the power
or 5.
Notice there's plus signs there, not multiplication signs. If it was multiplication,
just add them then.
35.
It's 35, but what's a shorter way to find that?
7 times 5.
7 times 5, right? 5 times 7.
And I thought of that. I was like,
I don't know if any bells going off yet? Let me move this over to the side. Okay.
yeah, so it's going to be 35 to the power of 4 plus 5.
No. We can't multiply that because of those powers there. So we can't multiply that, sadly. But I'm just trying to show, this is a commercial break, remember.
So
7 plus 7.
And let's say in my commercial break that I decided, you know what, I'm going to subtract 1 7 from these 5 sevens. What would happen there?
That still makes sense.
If I had 5 of these 7s, and
It becomes 4.
okay.
And I take away a 7, these 7s right here will literally cancel out. And how many 7s will I be left with now?
4.
4 7s.
Oh, okay, the bases are the same.
So what happens if I now change everything around now? So let's kill the commercial break and go back to reality here.
Okay, so
Instead of having no 4s there, what if I now put a 4 on each of these 7s for my exponents? Will the same theory still apply?
Yes.
And so what would happen if I took away from that one 7 to the power of 4? Well,
6.
I'm going to be left with
6.
not 6.
7 to the power of 3.
7 over 3.
I'm looking at the.
No, I remember we're going to treat 7 to the power of 4 as just like one little entity. So if I had 1 7 to the power of 4, and then 2 7 to the power of 4, then 3 to the 7 power of 4s, then 4 7 to the power of 4s, then 5 to the 7 to the power of 4s, I could just write it as 5 7 to the power of 4s, right? No different than if I drew cat faces. If I had some cat faces, these are some ugly cats. Don't worry about these guys, right? If I had cat faces here.
Okay.
How many cat faces do I have here?
5.
5. And let's just say I wanted to write, I just have 5 cat faces. How many 7 to the power of 4s do I have there? Down bottom in pink.
5.
5. And if I take away one of them, how many am I left with?
4.
4. No different than if I drew 5 cat faces and I took away one cat face, How many cat faces do I have left?
4.
4.
But but Mr. Ray, so how come we cannot apply that? So over here on the, it said 5 times 7 to the power of 4 plus 5. So we can say.
Well, we can't add these because this is not saying I have 5. Let's say they're cat faces.
Oh, okay.
I don't have 5 cat faces right there. That just says 5. That could be 5 bananas. That could be 5 earphones. That could be 5 watches.
So this is okay. So we cannot add those two.
No, they are not the same. They're not similar in any form or fashion. That could be 5 apples.
Oh.
But what I do know I have, and this is why you have to understand the basics of math, 5 times anything like that just means I have 5 of those items, whether it's cat faces or pigs.
Okay. I'm seeing
right?
it. I'm seeing it now.
Yeah.
Okay. Yes.
So 5 times any number just means I have 5 of those items.
I got it, Mr. Ray. I got it.
All right. Good.
So it's so that being said, is 4 times 7 over 4 plus 5.
Ah, there we go. Yeah,
right?
that's the answer.
So I have 5
right?
to the 7. Okay. I have 5 of 7 to the 4th power.
Right. Is that
Say it again, Gennaro?
I have 5 of the 7 to the 4th power, not 5 times 7 to the 4th power.
Well,
sometimes when I see parentheses, I think multiplication.
It is multiplication. That's what we're saying. It is multiplication. But you got to think about what is multiplication. Multiplication is a shorter form of addition. It just means instead of adding something 5 times, I can multiply it by 5.
See,
okay.
What threw us off, Mr. is that the 5 plus 5. So the 5, we just leave it alone because really there's nothing to do with that plus 5.
Yeah,
so all we do is minus that 7 to the power 4 one time. So we got 4 to the power 4 times 7 to the power of 4, because obviously we took the 7/4 plus that 5, because that 5 we're not adding it to anything. Otherwise we'll have 10 times 7 to the power of 4. And even if we try that, it wouldn't come up on the answer. So okay.
Right. There you go. You got it. You got it, Salvador. You got it. That's how it works.
So what's the final answer?
So the final answer, I'm going to erase what I hoped helped you a bit.
Because I'm lost right here.
Don't worry. This part does confuse people. This is bridging us into algebra. And that's what we're doing after this lesson anyway. We're going to be doing algebra starting next week. So remember, that's another commercial. I really want to make sure you guys understand that. Let's say I replace 7 to the power 4 with cat faces. And remember, cat faces just means I have how many cat faces there?
5.
5 of them. Can I add 5 cat faces to a random 5?
No.
They're different.
No, I didn't even know what that 5 is representing. That 5 could represent, like I said, 5 fingers. Is it 5 t-shirts? It doesn't tell me, so I can't add it together. I can't say 5 plus 5 cats is 10 cats, right? Like literally, just think back to reality. If somebody said to you, hey, look, there's 5 cats out there. Hey, look, 5. 5 what? That hopefully is your response. If somebody said, look, 5, what are you going to say to them? If somebody said to you, 16, what are you going to say to them?
16
what?
16 what? You know, what are you talking about? You know, we always attach just by nature, even for a child that's learning, we by nature, we attach something to the number. This has nothing attached to it. Do you understand that?
So no exponent. The 1 5 has no exponent, right?
It has nothing to it, right?
Right.
So we can't do anything with this. It's tempting to add, but we can. If you treat it like a real life entity, there's nothing you could do with it. But this right here can be represented by cat face. And if I have 5 cat faces and I'm taking away 1 cat face, how many cat faces do I have?
4.
I would have 4 cat faces, right? And what about that 5?
Just put a plus sign because you're going to leave it alone.
And we're done. But change the cat face to 7 to the power 4. And what would our answer be? A, B, C, or
Mr.
D?
Ray?
Yeah, A.
Now, I know a lot of people are like, what is this for cat faces? We're talking about cat faces and math today, I tell you. But hopefully you're seeing the connection between what I've been saying. I know some of you have caught it. Some of you may not quite. It's probably almost there. So let's try some more. Let's say I had here, I'm trying to make it similar. Let's say I had.
Mr. Ray?
Yes.
Just a quick question.
Yes. Go ahead.
My computer is breaking up a lot. It has very bad reception.
Connection.
So, what's the right answer on the last one we just made?
It was A. The answer was A. Can you hear me?
Okay, I can hear it well. That's fine. Thank you.
All right. The letter was A, just in case you didn't hear me. All right. Let's try these three. Can you simplify these three questions down to their smallest way of writing it? And maybe I should have spaced this out some.
Okay, let's see.
And this is where we'll finish. And then on Tuesday, we'll pick up here. Now, don't feel bad. Normally, this, like I said to you guys, normally this takes a while in every class that I've taught.
Okay.
So just to kind of assist there with the first one. So for the first one, think about what looks the same. I have 6, 3 to the power of 8. Then I have -2, 3 to the power of 8.
Mr. Ray, I send you the first one.
No, you don't have to add the exponents because we're not multiplying the bases.
Okay, let me see if I got number one right.
Right.
It's number one.
So basically what you have to notice here are that this and this are alike. They have the same terms. The numbers in the front are telling you how many of them are there.
Right.
So there are 2 groups of that and 6 groups of that.
Right.
And if you have 6 groups of 3/8, 3 to the power of 8, and you're going to take away 2 of those groups, how many groups do you have left?
Right. Times.
4.
Set
4.
number 1.
So you're going to have 4 3 to the power of 8s left. And what is still left from that expression? Plus 3.
Oh yeah, I forgot to add that part.
But yeah, I see it, Gennaro. That's correct. That first
I was
part.
typing it quick. Yeah, I forgot the
Yeah.
plus.
You're trying to get it in before, like, no, I know, Mr. Red.
It's because
Well
I'm
done. Yeah, you
getting,
got that in.
getting.
And I couldn't pick up who said it. I don't know if it was you, Justine, but whoever said 4 to the power of 3/8, that was correct. All right. The next one. Look, this is 2 to the power of 5. This is 2 to the power of 5. How many 2 to the power of 5s do we have? We have
2
4
to the
groups of
10.
them. If I was to
2 to
write
the
it out, I
7.
have 2 to the power of 5 plus 2 to the power of 5 plus 2 to the power of 5 plus
7.
2 to the power of 5.
Is it
Well,
2 to the
close. It's not
2 to the 10?
7. Notice there that we are not going to add that 3 together because that 3, we don't know what that 3 is.
Oh.
We try it again with you. 3. If I just said 3, what do you say?
3 what?
3 what? Right? I don't know. 3 cats, 3 dogs, 3 bananas, you know. But if I say 2 to the power of 5, I have 4 2 to the power of 5s. I have 4 of them. And over here is just 1 group, right? It's just 1. And so I can subtract them. And if I do, if I have 4 of them, and I take away just this 1 group that's there, I have 4 groups there, 1 group there, how many groups would I have left?
3.
3. So that means I'm going to have 3 groups of 2 to the power of 5. And what's left from there?
3.
Plus the 3. And we're just hit time, so let me just hurry up with this last one. I got 1 minute. Can anyone figure what this is before I finish it off? I have 3 groups of 2 to the power of 3. There's 1 group over here. If I have 3 of those and 1 that I'm going to take away.
So that's 2.
2 plus 4?
There we go, Justine. I see it, and I hear someone else trying to say it, but yes, Justine, that is correct. 2 to the power of 3 plus 4 is going to be that answer.
I guess I got mine wrong.
All right, so that's where we're going to end today, but what I want you to try with the worksheet is number 8. Now, of course, I can't stop you from looking in the back of the book, but I want you to try to have it written out, try to see if you understand it by, what day is that, Tuesday. And also, if you can also try, of course, these are all tries that I hope you can do and attempt in the workbook. And if you have to run, I totally understand. I was really trying to hope you can get there today. But if you can try in the workbook, can I clear this? Does anyone need that? I just want to write down.
Got it.
Got it.
Okay, so in the workbook, you're going to try page 71, number 4, 5, 6. I should have just said 4 to 6. 4 to 6, and number 21, 26, and that's it. So numbers 4, 5, 6, 21, and 26. And also, that's from the workbook. Also, the page we're just on, page 57 in the student book, number 8. Right. All of those deal with what we just done. The worksheet that I sent in Remind, that's the stuff that we were doing on Tuesday. So, you know, I know it's the weekend, but if you can just carve out some time, even if it's 20 minutes a day, between now and Tuesday. If you don't work on the weekends, then try to do it Friday, Monday, and Tuesday before class. And those are the numbers that you want to try. Even go over these. Try to grasp it. That's a part of learning. And yes, you're going to have a little bit of challenges because now we're entering into the realm that the average person does not know. And that's one reason why we're doing the GED test, right? Is so that you can know how to do these things, right? Unit 1 was the stuff that you learned as a child and might have learned in high school, etc. This is the stuff that you need to learn nowadays if you want to go up higher. Don't think it's silly. It actually is legitimate. All right, so I'll see you guys on Tuesday, unless you have any pressing questions. Enjoy your weekends as much as you can. You can enjoy your weekends learning. Learning is fun. And then the other thing is just be safe, and I hopefully see you guys Tuesday.
Thank you, Mr. Ray.
Thank you. Have a good weekend.
Thank you.
Yes, you as well. And keep up the good work, especially if you got some right today.
Thank you, Mr. Ray.
You're welcome.
Thank you.
You're welcome. Have
We
a
need
great
to do
evening.
more work.
Oh, there you go. That's
Yeah,
the
we need to do
attitude.
more. Even
More
when we
work.
do it without the right answer, at least we need to go through again before we go to the new subject.
Yeah, we're going to do some more practicing on it.
Okay.
Okay,
Bye.
see you Tuesday.
Yeah, see you Tuesday.
All of a sudden, it doesn't matter all of a sudden.
Tuesday, Mr. Ray.
All right, have a great day. See you guys.